In 2019, we began to build our dream.
But the journey started long before you were invited to watch.
We walked a path that spanned nearly 2 decades.
There were times of joy, pain, and everything in between.
Our lives have completely changed, and we're ready to tell you how it happened.
We're not holding back.
Our mistakes, regrets,
What we wish we could change, our best decisions.
and if we do it again, you'll hear it all.
Come back in time with us behind the camera and answer the question,
Is self-building worth it?
Rolling.
All right, let's do this.
All right. All right, welcome back to Mr. Post Frame. Today's video on our series, Is Self-Building Worth It?, is the under slab in-floor radiant heat prep.
Yeah.
And this is exciting. The way I did this in this video worked great. We do it differently now, which we can talk about in the video. Let's go ahead and talk about design real quick. Our patron group for you self-builders out there.
Sure. So head over to back40buildings.com if you would like to work with us when it comes to designing your Barndominium. We do specialize in post frame, steel frame, and stick frame construction. And we would also love to see you over on Patreon. That is where we hang out with DIYers on a regular basis. There is some sort of live Zoom meeting about once a week. There are chats that you can get in. It's a great way to get more personalized access to Paul and I.
Keep going.
Yeah, I'll keep going. But in-floor heat, this is a very popular option. We build in central and southern Iowa. We do have 4 seasons. Winter, it gets cold. So all of our projects we bid out with in-floor heat preparation. So this stage of it is a minimum in all of our builds because we do strongly believe in having proper insulation underneath your slab and then the in-floor heat tubing on top of that. It's a pretty minimal upfront expense to add the tubing so that you can have in-floor heat right when you're building or down the road if you need to save the money.
Yeah, so I guess let's go ahead and, is there any questions that stand out from this video? I mean, just looking at this, I remember, man, it's so exciting. You see the framed walls. I didn't have the steel up on the walls because I was trying to get the concrete done before the winter hit so that I could keep working through the winter. So I just stopped on the steel. But I do love this phase of a build, you know, where the plumbing's all in and you're starting to put the insulation down and whatnot.
Yeah. Yeah, no, it was definitely an exciting time. We're in October of 2019 at this point in the video. So yeah, a lot of the questions on the original video are some of the most common things that we get asked when it comes to in-floor heat. So if this is kind of your first introduction to in-floor heat, what you might think in your mind is that it is what I call heated tile in your bathroom type of in-floor heat. And this is different. So Paul, how about you give us the more technical explanation of why we're not doing in-floor heat for the purpose of making all of our floors feel like warm or hot to the touch?
Yeah, so it's hydronic heat. So you have a series of tubes PEX tubing ran through your concrete. You have a boiler or a way to heat the water or glycol that you're running through that. It heats up the slab to whatever temperature you set it at, which heats up the walls, everything to that temperature. So it's a very consistent, it's very efficient. Concrete is a huge thermal mass, so it'll hold that heat for a very long time. I would say the only downside to radiant or hydronic heat is it's not a quick turnaround. So if you're sitting there feeling cold and you turn the heat up a couple degrees, it's not like an HVAC forced air system where 5 minutes later you're going to feel warm air. So you have to kind of look at the forecast, look ahead, but it's a very consistent feel. It recovers like if you open a door, even in your garage, if you open the door and a bunch of cold air runs in, it doesn't necessarily kick the heat on because it's going to take a lot more than just the door open for a few minutes to make the concrete cold enough to set the heat on. So it's very efficient. It's a great base of heat for your home, your garage, anything like that.
Yes, so it's a different type of situation than like the luxury of having your tile in your bathroom be warm when you're walking on it. You don't go for that with this. This is actually to help increase the efficiency of your home.
I mean, you could put a zone in your bathroom and crank it up but it's not, that heat is not going to dissipate as fast as like an electric radiant heat under tile.
Right, right. So yeah, that's meant for it quickly heats and it quickly cools. It's meant for it to just go back and forth and be used just when you need it. This is about increasing the efficiency of your home. This is can be used as a primary heat source.
Yeah.
But we lived in the garage for a year, and the in-floor heat in the garage was the only option we had for heat. And we had one of the coldest winters we had had in a very long time. And while I would say in-floor heat isn't as cozy as a fire or, feeling like a furnace blowing warm air on you, it does keep you warm. So
Yeah.
it kept us comfortable enough to live in there, and we didn't have any problems.
It's so efficient that we just set our garage at 65 once winter gets here, and we leave it. I mean, it's still at 65.
Right. Yeah. And from, a lot of the other comments, we get are related to cost, which we always, like I said earlier, we always encourage that people at least put the tubing down, because that portion of it isn't as expensive as the control panels. And so you can always save putting up your control panels until down the road. Or a lot of people end up just going ahead and doing it right away because they like the idea of being able to have that as a heat source immediately. For us, it has really helped us save a lot of money with our build. We use our wood stove as a primary heat source, and we use the in-floor heat. And throughout the winter, it is very common for us to have the furnaces turned all the way off.
Yeah, the only thing I use the furnaces for in the winter is I put them on circulate so they'll move air around.
Right. So we have a traditional HVAC system mainly for the air conditioning component. The in-floor heat does a great job. The wood stove does a great job. We are heating the main house and the garage, so it's about 4,600 square feet of concrete that we have in-floor heat in. And I contracted 850 gallons for us this past year. And I think that we still have a few hundred gallons left. And at the time, like right now, this is about the time that you run out. Like you're supposed to have used everything in your contract at this point, and we still have a couple hundred gallons left on it. So it is very efficient. If you know anything about propane, you know that that's not very much usage for a cold winter.
Sure. Yeah, so I guess let's jump into the video and we'll kind of talk about some of the installation things that you need to think about. All right, guys, the time has finally come to start putting down plastic and insulation. I'm super pumped about that. I got this re-leveled half of the house part. I put my string lines back up, added some gravel and some low spots since I've been doing a bunch of digging. So back when I did this, I was using a plastic vapor barrier. Very important in any slab that underneath it you put a vapor barrier. All of our slabs at bare minimum, I want a vapor barrier and insulation. As far as living spaces, you want to frost protect. I frost protect. I frost protect everything. It's one of those things that you should do. So here where we are in the Midwest, we go down 24 inches along the edge, down along the grade board to protect from frost. And then our insulation will die into that. And that's how we insulate. Back then I was using the pink board. Now we have a partnership with Hitzholzer Insulation, which is an EPS foam. So it holds its R value better over time. It doesn't absorb any water. And the great thing about this insulation is that it has a double vapor. It has the vapor barrier built into both sides. It has grid lines on it. It has terminicide in it, so it kills insects that try to burrow if they get into that far. And it really speeds up the process. And the new sheets cover 96 square feet versus 32 square feet. So the speed of the insulation is much faster. So.
And cost-wise, it's very comparable.
Yeah.
Yeah.
For
So
sure. And for residential, like the EPS foam, like the manufacturer, for residential and light garage, you only have to use a 15 PSI. And so, it's very comparable in price, and it has so many other great features. I can't tell you how much of a pain in the butt it is to put plastic down on the floor. And then, if your gravel isn't perfectly flat, your poking holes in your plastic. So that
Yeah.
that was frustrating, which with the way this product is designed, it's much better.
Yes, exactly. And if you have something that's not just light residential, then there are different.
Oh yeah, they go all the way up to like, I know they go to 40 psi. They might even go higher than that.
Sure. And
But
that's for your big agricultural equipment,
yeah, I mean that's when you're
stuff
going to
like
have
that.
like 8-inch slabs and stuff like that.
Right. Yeah. With semis and stuff. But yeah, you talk about this step a lot, because sometimes people will not want to do this. I think that it's one of the reasons why people thought that barndominium homes would cost a ton less than a regular home is because maybe you would build a pole barn and you wouldn't do any of this part. You wouldn't insulate, you wouldn't add a vapor barrier, things like that, because this is several $1,000s in material, this step of the process.
We
But
have a cost breakdown of what it kind of costs per square foot. But on that note, even if you're building a shop and putting a concrete floor in there, you want a vapor barrier, and you should be putting insulation under there because it will keep that space so much nicer, and it's the proper way to do it. So, I mean, there's plenty of people that don't, put anything under their slab in their shop or their garages, and then they can't understand why that their floor is sweating all the time. Well, it's because the ground moisture is coming up through the concrete. Concrete is very porous, so that's why it's important that you get that vapor barrier.
right, yeah. So it's one of those things that people can manage and get away with it, but it's not, if you're going for a really well-built home, it's not something that you want to skip.
Yeah, because if you do insulate under your slab, we use closed cell spray from the walls. We have, like in our house, we have an R60. This house would never drop below freezing. I mean, it would get cold. It would get into the high 30s, but it would never drop below freezing in
Right,
here.
right. And you would use this if we lived in a more mild climate, you would still insulate.
100%, because if you think about it, that frost protection is going down and protecting the side of your concrete slab. So you're creating a thermal break. So even when the sun is, coming down, depending on where you are, 100 degrees, you get down to the south where it's 120 degrees and it's hitting that concrete, it's penetrating into that concrete, which is going to raise the temperature inside your house. So by putting the insulation down, you're protecting yourself and giving yourself a thermal barrier between that sun and your concrete slab, which is going to make your house more efficient. So I would 100% do this no matter. Now, would I take it down 24 inches? No, but I would take it down to protect the side of the slab.
Sure. Yeah, and now tell us a little bit about that. Can you explain why frost protection for the perimeter is 24? You do 24, but you've told me that that's even more than what is technically required here. And then the foundation, though, goes down further than that below our frost line. So can you explain that a little bit, why there's a difference?
Well, it comes down to what kind of foundation you have, where you're located. They have in the code, there's a map. It's called the freezing air index map, and that will determine how far you need to go down with your insulation. If you need wing insulation, so wing insulation is like horizontal insulation, and it spells it out for you. Originally, when you were frost protecting shallow foundations, which this is not a shallow foundation, our foundation goes down below the frost line. However, we do have a slab, so you still need to protect the slab. Originally, it was thought that in order for that to work, it had to be a heated building, and you couldn't have any insulation under it so that the heat could escape down below, which if you think about that, that's ridiculous because you're losing the heat that you're paying. Mm-hmm. But their engineering proves that taking your insulation down the side, the required amount, insulating underneath your slab, you're going to be retaining the ground. There's heat in the ground. It's the same reason that geothermal works in the middle of winter, is because there's heat in the ground. The ground is going to maintain somewhere around a 55-degree temperature all year round. So by going down and under, you're retaining that heat under the slab, and it's keeping the frost from driving in and freezing underneath. So, this is a normal practice across the country.
Yeah.
Really exciting part about this video is it's the first time Justin ever showed up on the scenes. There he is. Look at him.
Yeah, he's in the background.
So Justin was the assistant pastor at our church, and I shouldn't say this online because maybe Jonathan might. I doubt Jonathan's watching, but I'm like, someday, Justin, I'm going to steal you from the church. But Justin came out and helped me lay all the in-floor heat tubing in our garage. So that was the first time that we ever worked together.
Yeah, really good. Justin even made some comments on our original house plan and everything like that. So kind of fun. And if you don't know who Justin is, he's the guy who films all this, edits all this. So makes us look good. But yeah, so this is kind of, I think maybe address this a little bit too. You've had to put a piece of plywood up because with post frame construction, there are no interior walls at this point.
Sure.
And so you've had to put something up to secure all of the lines to.
Yeah, and you can see in the video, so depending on where your in-floor heat system is going to set, you'll have to have a place to land all of your lines and whatnot. So what I do is I'll just drop 2x6s from the ceiling. You might have to put some boards across from truss to truss to get it where you want. Then I'll put some angle braces on it to hold it where I need it, and then I'll set the bottom just so it's right at the top grade of the concrete. And then once all the concrete's poured, I can take all that down and build my wall. Mm-hmm. One thing I do is they actually make specific tubing to bring your tubes out of the concrete, but I just use 1-inch EMT conduit. It works perfect and protects your lines going in and out of the concrete, so there's no chance that they get damaged. And another thing we do is we'll pressurize all of these lines. We pressure test them after we install them, and then when the concrete's being poured, we will put them under pressure, keep an air compressor there, monitor it during the entire pour. So if we lose pressure, we can turn that air compressor on, locate the leak, cut it out, put a brass coupling in there, and fix it. It's only happened to me once, but we had a patron that it happened to, and he had it pressurized and he was able to fix it. Otherwise, you're going to lose that line because there's no going back.
Yeah. Yeah, so you definitely want to be available that when they are pouring your slab, you don't want to be MIA that day. You want to have that pressure, see how it holds and stuff. So, because it just kind of, sometimes you get off without any issues, but this is also another reason why you like to actually staple the tubes to the board. So we've been, there's some research that suggests that there is an increase in efficiency if you pull the tubes up into, and tie them to the rebar, or, like have them up in the slab. Can you kind of talk about why you're not a big fan of that and why you think that?
Well, there's a couple reasons, and I would love to see, I don't know how you would ever, I'm not going to ever have the money to test this, but as far as how we lay our tubing, we have a vapor barrier, we have insulation, so it's going to drive that heat up. So we staple our PEX right to the insulation, and then the concrete gets poured over the top of it. You're still surrounded by concrete, and it's heating that concrete up. The thing I love about it is then when you go to fasten all your interior walls, that your tubes are at the bottom of the slab, and any fasteners that you're drilling into the concrete aren't going to come close to breaking your line, because you have to know where your lines are in order, especially if you're going to pull them up into the middle. Because if you start drilling and you don't know necessarily where your line is at, you could end up damaging it. So we pour 5-inch slabs. That does a couple things. One, it gives us the extra mass. Two, if you've ever graded out a floor, it's almost next to impossible without taking an absorbent amount of times to get it absolutely perfect. So you might have 1/2 inch, 1 inch of variance. So if you're shooting for a 4-inch slab and you have a high spot in your floor that's 1 inch high, you're going to end up with a 3-inch slab there. So I would rather we shoot for 5-inch slab, and that way it almost guarantees that we're going to have at least a minimum of 4 inches of concrete everywhere. Mm-hmm. Now, we've gotten pretty good. So we're probably 4.5, 5.5 inches everywhere. But that's my philosophy with it. And then it also gives you plenty of room to set all your walls, put all your anchors in, without ever having to worry about damaging an in-floor heat tube.
We do get a lot of questions about like how somebody can get a hold of some of this stuff. As Paul mentioned, what he is using in this video is not the same as what he uses now in everything. And we do feel like how we do things now is a really solid way.
Yeah, there's always more than one way to do it.
Yes.
But
You've been
our
really happy
process
with
is
it.
very, very good. It's efficient. I'm more of a DIY person, so we do have a partnership that we formed with RadianTec. I've installed a couple of their systems. They've worked very well. They'll design all of your loop layout. They'll size your boiler. They'll help you design your zones, all that kind of stuff. So we can leave that link for that. We do have a discount code, correct?
Yeah, if you...
How's that going to work?
Well,
Explain
yeah.
that.
So yeah, if you let them know, so the way that any benefits would come to you through RadianTec is that you need to let them know that you're working with Mr. Postframe, and it just kind of depends on what it is that you need, what you're purchasing, and everything like that. They want to work with you on, helping you out in any way they can. They are a DIY friendly company, and so things are designed to be a self-install if you choose. They're very competitive in terms of their pricing on things, and as Paul mentioned, if you're purchasing like your tubing through them and your controls and everything like that, they are going to like spell it out for you. They're going to show you where to run all of your loops and how to install everything. That's included in your purchase. And so if you want to get a quote from them, just head to this description and they'd be happy to. They're very prompt. Happy to work with you on stuff. It is always a good idea if you do have your plans done to send them a set of your plans, because then it's very easy for them to see what you're working with, where your room locations are, because you've kind of self-designed some systems and stuff, but they are equipped for helping you figure out like how are you going to get everything back.
They're going to ask you questions like, hey, what is your insulation plan under the slab? What is your insulation plan in your walls? If you have a set of your plans, they're going to be able to calculate heat loss based on how many windows and doors and all that kind of stuff that you have. So they're going to be able to properly size, your boiler, your circulator, your lines, all that kind of stuff. So it kind of takes all of the guesswork out on your end, and then they provide you all of the pieces to put together. So so it is pretty cool. Speaking of like boilers, so some folks and tradesmen, DIYers alike, they'll use one like boiler or water heater to power the hot water for the home and to power their in-floor heat. So the boiler.
Yeah,
the boiler. It's a combination boiler. So you can definitely do that. Most of all of the new boilers will be dual purpose. You can run all your in-floor heat system off of it and heat all your potable water. So it's just preference. In our house, I separated them. So our in-floor heat was just on the boiler, and then all of our hot water for the house was on its own water heater, just on-demand water heater.
Yeah.
But they, a lot of the homes that we've built have done the combi unit because you can save money.
Yeah. Yeah. You save money on, like a tankless water heater like we prefer to use is around $1,000. So you're saving that, and then you're saving, if you are having somebody install, it's the savings on that.
Install,
so it's a little bit of savings there, and it takes up less room in your mechanical area. So if you're short on wall space, that is a way to kind of get some of it back, because most of the in-floor heat systems, the recommendation is that you have at least, I believe, 4 feet of wall space to dedicate just to that.
Yeah, I mean, I like to have a minimum of 4 feet because there's a lot of stuff that goes on the wall.
Yes. Yeah. So that's something to keep in mind when you're planning out your mechanical room, is that you do want to have good dedicated area for that, because it will make, especially if you're going to install your own controls, it's going to make it so much easier to work with it. And it's going to look a lot cleaner. You guys have seen our tours and stuff, and Paul, it took so much pride in our mechanical room is very neat. It's very tidy. And that's one of the reasons why is because there was enough room for everything.
Right. Which we can talk more about all the boiler and controls and all that stuff when we get to that point. I mean, this is all just the under slab prep part of it. And so just to go back to what you were talking about, to properly prepare underneath your slab, you need your vapor barrier insulation. So to add the tubing is a minimal cost. It's about $110, $120 for a 300-foot loop. So if you take your square footage divided by 300, that's going to tell you how many loops you're probably going to need. So definitely worth preparing, and then you can add the boiler, controls, all that at any other time.
Yeah, even if you're having somebody install it, I mean, I think that it's still worth having the tubes,
Yeah, this is very DIY friendly process here.
Yeah, very DIY friendly. We have quite a few clients who end up doing this part on their own because, once you watch some of these videos, it's not very scary. It's kind of hard to make a big mistake.
Yeah, I mean, it's some work, but Justin, you've watched me do this how many times? You've helped a lot. Don't you feel like you could complete this on your own?
Oh, yeah.
Never doing one on your own other than just helping me, you could do this.
So yeah, the insulation is definitely the pricier portion of this part of the job. And yeah, the stapler it's a $300 tool, but I think it is absolutely worth it.
Yeah.
Yeah, that's one of those things too, that if you're thinking, I'm only going to do this once, buy yourself the stapler. You can head to the description for that. And then you can always resell it when you're done, but it'll save you a ton of time, a ton of effort. It's so much quicker than if we were to try to tie all this to rebar. And it puts you on a time crunch too. Like our concrete crew, they're the ones who lay the rebar. So,
in the cabin, did I cover in-floor heat in that video series? Because in that series, I'm building a cabin for my dad. It's been like 5 years, and I think they're about ready to fire me. But when we did that, we rolled out the wire mesh and attached all the tubing to it. And I will tell you, I will never, ever do that again. That was so inefficient. It was so difficult. Never do that again.
Yeah. Oh, another question that some people will ask too is if, if you need to be careful about it, like melting your toilet wax rings or, things like that.
No, none of this matters. I mean, you can see in the video that I did kind of loop out around where the toilet's going to be and stuff like that. But this isn't the type of hydronic heat that's going to like melt your wax rings. You can run it under your cabinets. You can run it under your refrigerator. It's not, because your house is going to be, if you want your house to be 70, your refrigerator is going to have 70-degree air around it, whether it's hydronic heat or forced air heat. So it's not going to affect your appliances.
I know you've never lived in Texas, but would you do this anywhere in the country? Would you put it in?
I've never lived.
Because it's going to still get down to 30 in the winter. Okay.
I'm just unsure of like the South and how it works in the winter months. I mean, I don't know. It's too bad if there was a way that you could reverse it and cool your floor. That would be pretty amazing.
Yeah, that would be pretty amazing. I mean, I've talked through this with quite a few clients, and I think once you get to the parts of the country where the winter is typically very mild, you really only need to heat your house for a few weeks a year, unless you are doing a luxury project and unless your budget is a little bit bigger. Most people opt to just insulate and not do any of the tubing and the controls. But then there's also a sweet spot of like where your climate is just mild overall. So like summers aren't crazy, winters aren't crazy. This can be a really good option for folks.
I think if I was going to build in the South, I would prepare underneath my slab just like I do here. But I mean, eventually somebody is going to develop a system that's going to be an efficient way to cool your concrete. So when you think about that, throw the tubes in there, like it's going to happen. Somebody's going to do it. Somebody's going to I mean, there are systems out there that you can use. I haven't done a lot of research on how well they work, but somebody's going to develop something that can reverse this, and you can cool your slab too.
Yeah, which would be pretty awesome. That would
Which I
create
don't
a
know
ton
how,
of
like,
efficiency.
I just don't know how that's gonna, like, heat radiates. I just don't know how that's gonna go up. Will that go up and cool your, you know what I'm saying?
Yeah.
But and the thing with heat is you need a way to remove humidity, and that's why a forced air system, I like it the best because it removes the humidity out of the air. And so I don't know, just kind of talking through that. I don't know if I would do it.
Yeah. Yeah, I mean, it's a big debate. The other big question that people ask us all the time is, do you run it off of like propane, natural gas, electric? Like, you know, what's the best method for all of this?
100% a gas boiler is going to be way more efficient than an electric boiler. If you're an off-gridder and you're like, well, I don't know if you could, I mean, you would have to have a ton of solar panels to produce enough power, depending on the size of your house. If it's a small one, but I would definitely go gas, or there's some guys on our patron group that are going to do wood boilers,
Sure.
which I'm really interested to see how that turns out for them, because it should work good.
Yeah. Yeah, but most systems do come with the capability to like go either direction, or it's an option. I've been told by a few contractors that if somebody wants to like convert one to the other, like it's not really that difficult of a process.
You would just have to switch out the boiler
Right.
from a gas one to an electric.
Yep. So yeah, so you have a lot of options that way. Just kind of, and some of it does boil down to like, what are the costs for those things in your area too? So you do want to keep that in mind. That utility costs will vary across the country.
Yeah, we have one patron in the out east, and he has a natural gas well on his property, so all of his natural gas is free. So how cool would that be?
Yeah, that'd be pretty cool. So that's an easy decision for somebody like that. But we'll get into more of that when we talk about the down the road, way down the road, when the house is actually put together and we're finishing things up. You'll see the controls come in, and we'll talk about that again. But head to the description for everything that you might want to check out for your project.
Yeah.
Let's wrap it up.
So as always, we appreciate you guys watching. If you haven't already, hit that subscribe button, share us with your friends, and we will catch you on the next video.